Hello everyone, on behalf of Solar Quarter India and First Year Group, I am Priyanshi extending you a warm welcome to each and every one of you to today's webinar on Tech Insights Robotic Cleaning in India. It is my pleasure to be your host today. We would like to extend our gratitude to all our esteemed guest speakers and the attendees for their valuable presence in today's webinar. Your active participation will contribute to make this event a great success. Welcome to Tech Insights Robotic Cleaning in India, a groundbreaking webinar that provides a deep dive into the latest advancements in robotic cleaning technologies and their impact on the renewable energy asset management. In response to the growing demand for advanced maintenance solutions, Tech Insights Robotic Cleaning in India serves as a platform dedicated to offering insights into how these systems are transforming the efficiency of solar panels and wind turbines. Learn about the pivotal role these technologies play in advancing innovations in the renewable energy sector. This webinar is not just an informational gathering, it's a call to action to explore technological updates, successful real world applications, and emerging trends shaping the future of sustainability in India's renewable energy sector. Thank you once again, everyone, for joining. Before we start the panel discussion, I take the pleasure to welcome on the screen Mr. Atul Pachori from Serentica Renewables to give a knowledge presentation. Sir, please take it ahead.
Yeah, thank you, Priyanshi, for giving me this opportunity. Because when we talk solar, so what we are doing, why we are installing solar, everybody knows that in order to make some green footprints on the earth and to save our earth from getting it worse and worse. So earlier were the days when we were using the manual method to clean the modules, because cleaning of the modules is a necessary aspect, everybody knows. So it's a very little presentation which I would like to make. So everybody, if you have any question, then in the last we can ask, but yes, let's focus on that. Hope the screen is visible.
Yes, sir. Screen
Fine.
is visible.
Very good. So this is a very famous photograph which is published on WhatsApp or maybe in Facebook and everywhere. The module itself speaking, please clean me, right? Then robotic cleaning of the solar modules. We'll focus today on the solar modules only. Although we can utilize this robotic cleaning for wind turbines also, but let's focus on solar modules today. So the question arises: it is a luxury or the necessity? So we can derive by itself that is it a necessary or a luxury by asking by itself after this presentation. So let's know some facts as of day. Water needed to clean one module is approximately 1.5 liter. I'm talking about a 500 watt peak typical module. So we need 1.5 liter water to clean one module. After that, how many panels we have in a plant? Let's say it's a typical 100 megawatt plant, although we have several 100 megawatt plants now. So we can multiply it for deriving other things. So almost 2 lakh modules, 200,000 modules are there installed in a plant. Then we have total water needed to clean the plant once is, it's a simple mathematics to it. 300,000 liters of water is needed in order to clean the plant once only. And we know that for a typical Rajasthan area or maybe in Madhya Pradesh or Gujarat, we need almost 18 cycles in a year to clean our plant. And then we clean the modules with the help of tractor arrangement, where a capacity of one tanker is almost 3000 liters. So when we say 3000 liters, and we need 3 lakh liters of water. So now total number of tankers are needed, 100 tankers are needed in order to clean the plant once. Now, if this is a tractor, it's a trolley arrangement, then it will bring the water from somewhere. So the average mileage of a tractor is 7 kilometers per liter while it is running for carrying the water. After that, if we'll see distance to travel carrying the water, almost approximately 20 kilometers is the distance, average distance, which is needed to carry that water, which is required for cleaning the modules. After that, we have diesel consumption also. To bring the water is 2.9 liters of diesel we are consuming in order to bring the water into our plant only, right? After that, we have diesel consumption for 3000 tankers is 8571.4 liters. It is specific, I've calculated in mathematics only. So this much amount of diesel is needed in order to bring that water to clean the plant once only. Then each hour of running, because the modules will be cleaned with the help of a pump, in order to run that pump we again need that the tractor should be running up and running. So almost 3 liter of water each, 3 liter of diesel each hour we need while cleaning only. Almost 8 hours we clean, 4 hours in the morning and 4 hours in the evening. So we need approximately 10 days to clean the plant, whole plant, with that frequency. And total diesel consumption is 240 liters. So now we'll calculate each and every aspect of the diesel consumption. And while the diesel is burning, we all know that it is emitting the CO2 in the environment. And why we are installing solar plants? In order to protect or prevent the CO2 emission in the environment from other electricity sources. So now we are 2.7 kg of CO2 is emitted from 1 liter of diesel burning with the help of tractor. And then further, if we'll see, total CO2 emission for each cleaning cycle is 23,526.5 kg. Means this much amount of diesel, this much amount of CO2 we are emitting in the environment in order to clean those modules. So is it really viable? Is it really a green thing what we are doing? Is it really sustainable? Those questions we really have to ask. If we'll answer these questions, then the question number one, is it a luxury or a necessity, that can be asked. That's it. Thank you.
Thank you, Atul, for that nice ice-breaking presentation.
Thank you so much, sir, for the insightful presentation. It was really great. And it has set up the tone for today's webinar and the panel discussion. I would like to make a small announcement. Attendees are requested to post their questions in the Q&A box, and this will be answered at the end of the panel discussion. So I encourage all the attendees to actively engage in the discussion by posting their questions, interesting questions, and our panelists will take it after the panel discussion. So without any further delay, let us begin with our highly anticipated panel discussion session for today. It is my pleasure to introduce our esteemed panel of speakers who will be sharing their insights and expertise on this topic at hand. Mr. Sundaresan from Infosys, Mr. Charu Mathur from Sunpure, Mr. Gaurav Gaba from Leapting, Ms. Priya from Soulbright, Mr. Atul Pachori from Serentica Renewables, Mr. Kalpesh from O2 Power, Mr. Rohit from SolarLit. And the moderator for today's session will be Sundar sir. So thank you everyone, and over to you, sir. Please take it ahead.
Thank you, Priyansi, for that wonderful introduction. And the floor is open for the panel discussion now. And I first call upon all the experts who are going to present their panel discussion today to share their small profile. And let's have a good one round of introduction for 5 minutes, right? So I'll first invite Charu Mathur, Senior Account of Director from Sunpure, to introduce himself first.
Thank you, sir. So myself, Charu Mathur, and I represent Sunpure. So first, I'll continue with. Shall I continue with Mr. Atul Pachori point.
Sure. Yeah.
And what Atul Pachori have pointed out on the calculation of CO2. But here I would also like to focus that how much revenue what people are losing out when we go with water cleaning, and which sir have said about that is 2 lakh modules, so which is cleaned every 15 or 10 days. And if we consider 2 rupees of cleaning cost of single module, the yearly cost will be nearly a crores. So on the economics also, if we calculate the water cleaning is too high, and this is for today's scenario. In coming time, that the the cost of water, the cost of manpower will increase, and it will also impact the calculation which has been considered in the financial sheets. So that one of the major reason why robotic cleaning is being considered aggressively in the Indian market. So this is my thought in this point what Atul Pachori have put in, and in coming session I'll say more about the financials.
Yeah, thank you. I think, in fact, many of the companies started reporting in their ESG report. In fact, even Infosys is also reporting for the past 3 years, and we are carbon neutral for the past 4 years, right? So, in next, I'll call upon Gaurav to introduce himself.
Hello everyone, this is Gaurav Gaba. I represent lifting and I work in lifting as sales director for Pan India. So I have total approximately 15 years of experience in solar power sector. Uh, so yeah, this is about me and looking forward for the rest of the session.
Thank you, Gaurav. Next, I call upon Priya to introduce herself. Priya, you are talking on mute, I guess. Maybe you can unmute and talk. Priya, are you there?
Priya ma'am, we are not able to
Oh,
hear you.
sorry, it was some mic problem. Hello,
Yeah,
everyone. I'm
thank
Priya
you.
Gupta here. I represent Soulbright in India market, and I head overall operations. Either it's a sales, after sales, project management. So overall, I'm representing as a country head for the Soulbright. And thank you, everyone. Let's move on to the discussion now.
Thank you. Next, I call upon Atul to introduce himself. Though he made a presentation, but I would like to introduce himself.
Thank you, sir. So this is Atul Pachori, and I am representing Serentica Global today. So we are a independent power producer, and I am heading as the asset management department of Serentica Global, which is a part of Sterlite Group only. And I am the last user, so end user of this product. So this is very thankful to all of you to for attending this webinar, and I'm sure that by the end of this webinar session, we shall be able to conclude that yes, it is wise choice to use the robotic cleaning for our modules. Thank you.
Thank you. Over to you, Mr. Kalpesh. Please introduce yourself.
Hi, I'm Kalpesh Numretia. I'm representing O2 Power, which is the 4.5 gigawatt of solar and wind IPP. I am leading asset management of solar and C&I assets at O2 Power. I have total 14 years of experience, out of 14, 10 years in renewable portfolio management. So as Atul said rightly, we are the last user in the value chain of this robotic cleaning system, and hoping for a great session.
Thank
Thanks.
you. Mr. Rohit, would you introduce yourself?
Yeah, hi everyone. Myself Rohit. I'm representing to the solar lead as a technical. I have total experience of in the renewables 10 years and total experience of 15 years. So it's very great that we are having a such platform for the knowledge sharings, and I look forward for the further sessions. Thank
Okay.
you.
Thank you. Let me quickly introduce myself. I am Sundaresan Puvalingam. I'm a distinguished technologist with Infosys. I have 22 years of experience with Infosys and overall 33 years of experience. I had integrated product development, including robotics and autonomous system, including various technologies like IoT, sensor technologies, and other allied technologies, AI, Gen AI kind of thing, right? I also own solar panel cleaning robot pattern. So next, let's start moving with our robotic cleaning in India, how it shapes up and how it is going to cope up with India's ambition of doing 500 gigawatts of power generation, not using the fossil fuel. Right, India has given a commitment for 500 megawatts of renewable energy development, right? So again, today when we talk about any product, it's all smart, connected, and again, system of connected systems and products we are talking about. In fact, when we want to go home, also we wanted to remotely switch on our AC so that when we reach our home, we wanted to feel the comfort, right? So again, everything is becoming IoT driven, sensor driven, and AI driven. And just I would like to ask my first question to our panelist, Gaurav. Can you discuss the integration of IoT and other allied technologies on the robotic cleaning process?
Thank you so much, sir, for the question. So I'll first start with a brief introduction of the company, and then I'll move on with the answer. So Lifting is a China-based, Shanghai headquartered company. Started in 2020. So we provide smart O&M robotic solutions for PV power plants, not limited to only cleaning robots. We also have module inspection robots as well as module mounting robots. So right now we have total 4 products. Since this session is more focused on the cleaning robots, but still I'll briefly touch upon the other components also, because the question is related to artificial intelligence and IoTs. So I'm proud to say that Lifting is the first company to introduce fully AI powered robots for the smart O&M of the PV power plants. So we have 2 types of cleaning robots. First is, we call it generation 1, which is similar to others, which runs on the frame of the module. And then the other robot that we have is the generation 2, we call it G2. That is the vehicle based robot, which is self autonomous and self navigating. So you map the route and it automatically navigates the whole power plants and clean the solar panels. So it's fully automatic, also reduce the structural parts. There is no hindrance in terms of the misalignments, or in terms of the angles or the table displacements. So yeah, I mean, all the products are fully integrated, or all products can communicate to each other really well. So for example, our module inspection robot can, while doing the inspection, it does the visual as well as thermal inspection. So while doing the inspection, it can give direction or signal to the other robot, and tell them that, okay, on so and so row there is a bird drop issue, or there is more dust. So it can give signal to the cleaning robot to clean that particular row. So yeah, all our products are fully integrated and fully AI powered. Not only the cleaning robots, but the inspection robots as well as module mounting robot. And we are proud to say that all our products are commercially applied in India market. uh, we have total signed approximately 7.5 gigawatt in India. Out of that, 2 gigawatt is already supplied, and around 1.5 gigawatt is already commissioned. So yeah, in terms of products, we are taking AI very seriously, and most of our robots are fully compliant with the artificial intelligence, which is the future.
Thank you. Kalpis, you would like to add your comments from your end?
Yeah, thanks, Mr. Sundaresan. So I think when we talk about the integration of AI, IoT, and ML, so we know that all of the robotic cleaning system which is available presently commercially in the market are having a certain sense of smartness. I would say that now it is fully coming with the SCADA system. We can schedule automatic cleaning. It has its own insight, like it can decide whether to run now or not based on the weather input from the site. But there are certain more things that can be integrated into the robots in coming days. And that I would suggest that, let's say, first integration could be integration of robot SCADA with the weather data sources. So robot itself can define automatically when to clean. Let's say that there could be two type of cleaning schedules, right? One is the time based automatic, wherein fixed time has been given feeded into the SCADA system, and every day it run at the same time. Other could be intelligent automatic schedule, I would say, wherein a robot can take insights from the weather sources, define their own cleaning schedule. Let's say that today at 5 o'clock it is going to be windy, so it will not operate at 5 o'clock. It will select the time slot when there is no wind. So you can have a cleaning of the day. Otherwise, you will not able to clean on that day if there is a high wind at the defined time schedule. So this is one of the areas. Another area could be like one of the major challenges of now in the industry is the like bird droppings or the humic acid deposition on the PV modules or other such kind of deposition which robot is not able to clean itself. So if we can integrate like a visual camera or any other sensor which can detect such kind of deposit and either alert to the developer by way of alarm system, or it have a certain mechanism to specially clean such kind of deposition, it will much helpful, I would say that, to each and every developer, and it will enhance the life of the PV modules. One another integration could be possible, like a robot can be integrated with infrared thermal sensors or thermal camera or EL camera, which can give like a temperature pattern of the PV modules, and that can be fed to the cloud-based system, and cloud-based system do their own algorithm and calculation and provide you like a performance degradation or the performance pattern of the PV module itself. So I can say that one of the biggest pain point of any developer would be how the module is performing. So that can be detected with the temperature signature, which is daily can be monitored through the robot, and further it can be utilized for the analysis and define what is the exact degradation in the PV modules. So I think these are some of the things which can be integrated in coming days, which further can be enhanced with AI ML and will be used for I can say that best use of the industry. Yeah, that's all.
Yeah, thanks a lot. I think the vision-based system and other thing, the thermal cameras also will be helpful in identifying any hotspot in the panel also, and you'll be able to rectify that cells which are impacted. And also there are a lot of wireless technologies available for communicating from your control system to the robot, and again taking the data back to your control station, right, the dashboard and other thing where you wanted to do. So a lot of technologies are available in terms of 5G or Bluetooth connectivity, LoRa communications, no? So that you are able to get the data back and forth, right? So moving on to the next question, again, I think Atul started with the icebreaker of how much you need to spend for cleaning the panel if you wanted to do it manually with water and tractors, and how much is the diesel, right? So what is the kind of economic impact we are going to have on the robot-based cleaning system, right? So the robot itself will be having some cost, and in addition, you need to operate it and have that Wi-Fi system and other things to be set up. And what is the kind of cost we are talking about? Maybe we may not be able to do it for household appliances, but whereas maybe for a large solar farm kind of thing only we will be able to do it, right? So maybe I would like to ask this question to Charu.
Yeah. So the commercial impacts, if I say, so robotic cost will be costing 1 to 1.5% of the total project cost,
Okay.
and the ROI while investing this amount of money will be coming between 24 months to between 36 months. It will be coming back the ROI.
Okay.
But still it is, I would say, the way the government is pressurizing to stop using groundwater, and the cost of the water is increasing and the labor cost is increasing, the ROI may be much faster,
Okay.
and
Okay.
the quality of water which is required to clean the water, clean the solar panel is also important. So
Okay.
considering all those factors, if we count, then as I told you, 1 to 1.5 is the total capex cost of robot, and the ROI is between 24 to 36 months.
Okay.
Second point, while selecting any robot, it is also very important to consider one important point, that this 1% of the robot cost of the robot cost will be implemented on the 60% of your project cost, that is module. And what we are going to achieve, because by doing this you have considered 2 to 3% high generation. So the robot become very important factor when you are going to select which robot, which technology you are going to select. So
Okay.
this 1% cost become very important for your 60% of your capex, which is solar module, to generate 2 to 3% of high generation, which is there for 25 years.
Okay.
So considering all these points, I think we should select a robot, or these are the economics which comes into the picture.
Okay, thank you. So if the government is not allowing the water usage, especially the groundwater usage, are we suggesting that one should go for rainwater harvesting and use it, or use some other alternatives like chemicals or detergents, which are again low cost? Maybe Kalpesh or somebody else can answer.
Yes.
So first of all, sir, I think I would like to little bit add to the Charu's rightly said statement.
Yeah.
If anybody, if any developer, they have three key pillars for selection of any module cleaning system, right? First
Yes.
pillar is the commercial viability. Second pillar would be like operational challenges, and third pillar would be like sustainability of the solution, right? So if I talk about first pillar, which is commercial viability, I would say bluntly that this is no brainer, because we are going to compare manual cleaning system with the robot-based cleaning system. If I see the capex of robotic cleaning system is somewhere around 2.4 to 2.5 lakh per megawatt peak, and versus if I have a module cleaning system based on the pressurized water and that's storage tank, it is somewhere around 80,000 to 1 lakh rupees per megawatt peak. So in this, if I select the robot, I'm going to have a 2 to 2.5% higher generation compared to my manual cleaning system. So let's say economics works for each plant differently. But if I take an industry benchmark, wherein average module size is somewhere around 540 watt peak, average array length of the project is somewhere around 500 meter, and tariff of the PV plant is somewhere between 2.5 rupees to 2.6 rupees, then I can say that whatever the investment developer is doing, its net present value is 450% higher than what is they are investing now. And if I talk about internal rate of return, I'm saying about without debt, it's a case IRR is somewhere around 49 to 50% for robotic cleaning system. So if any developer is like investing in robotic cleaning system, they are going to see two parameters, right? What is my net present value and what is my internal rate of return? In both parameter, it's like no brainer. Second pillar is like operational challenges. If I talk about like manual cleaning system, in manual cleaning system, you have a huge number of operational challenges. First thing will be availability of labor locally. Day by day, there is a scarcity of labor, and we are not able to find the suitable person to do the regular cleaning. Second will be like whenever the labor comes into the plant, you will have like theft, vandalism, stoppage of work, strikes, many things will happen. Let's say that in a manual cleaning, my average soiling loss is between 2 to 2.5% with the cleaning cycle of 15 days to 20 days. If there is a work stoppage for 15 days, that will go to 5%, and the 5% of soiling loss would be like unbearable for any developer. So there are many reasons why developers are choosing robotic cleaning system. And
Hello.
So Kalpesh is somehow disconnected.
Yeah,
I
looks
think.
like, yeah. I
Right.
think he covered a lot of good points, and
Yes.
definitely I think the investment what we are going to get from the robotic based cleaning system is going to fetch its value, and within 2 to 3 years of investment you are going to get the things back, right? So
Yeah.
it's a good sign, and I think let's move on till Charu signs back. Will Kalpesh signs back. Will take the question to the next fellow speakers. So, Rohit, the question to you is, how are these cleaning technologies improve the efficiency of the solar panel? I know that the efficiency of the solar panel itself is not that great compared to the other system, but again, because if the cleaning is not efficient, then the power generated from the solar panel is going to reduce drastically, right? Even
Right.
25 to 30 percentage kind of thing. So, how it is going to improve the efficiency, and how we can control the downtime, right? So, I would like
Right.
to hear from you.
Yeah, thanks, sir. Just I will just brief little bit about my company. That Solar Lead is been presence in globally with the 220 gigawatt of project portfolio, as well as in India we have been secured nearly about 1.5 gigawatt, which is been secured project. Okay. And regarding the questions like the improvement efficiencies for the robotics, that as the robotic cleaning systems are been automated, which for the fully automatic we don't have any issues, that with the two-way cleaning we can able to get the 99.5% of cleaning efficiency based on the project locations and everything. Obvious that for the manual cleaning, when it is happening, as Kalpesh sir said, that the manual cleaning will have much hurdles for the EPCs and developers, as well as for the project sites also. Like the one is the cost, which will be very higher side. Then the manpowers, allocations, and every for the longer time for the project life. Another thing is say main part also will be the safety concerns for the manual cleaning, like snake bites and everything might be happens, like scorpions and everything. That was also the second is the if inefficiencies for the cleaning manually, going with the manual cleaning, that we won't able to guarantee that what will be the soiling loss for that same, and the controlling the cost for this manual cleaning, which we can't able to predict, where the Charu sir has already been initiated that it might be get increase and increase due to the financial sheets what we have been considering for this year, but after some time it might be changes the values overall projects. So for this the better way will be this, that the robotic system solutions where we can able to use for the much improved efficiencies can be able to guarantee it for the end clients for the projects. Thank you, sir.
Yeah, thank you, Rohit. I think you brought in the right point that even manual cleaning will be a problem with the snake bites and I think, and in fact, we faced similar challenges in our Hyderabad DC also, where we have 5.6 megawatts of installed solar panels, right? So we initially were doing the manual cleaning, and in fact, Hyderabad is a very hot place, and again, the temperatures can go to 45, 50 kind of thing, and it's inhuman to involve human beings there, right? Again, they may get sunstroke and other thing again, so that may impact the schedule, right? So
Right, sir.
it's a good thing to go with the solar panel cleaning with the robot based cleaning. So thank you for your
Yeah.
and again, Miss Priya, you are there online, and I would like to take the next question with you. So what are the latest technological advancements what we see in the robotic cleaning systems?
Hello, sir. Thank you for providing us the opportunity. First, I would like to tell some few points about the company. As the industry colleagues know, like Solbright is the inventor, and we exist in the market since 2013. If we talk about our global portfolio, it's around 25 gigawatt globally, and in India, operational portfolio is uh, 10 gigawatt plus. And if we talk about global application for this Solbright robotic, it has already surpassed 70,000 plus robots. So if we talk about our existence, we exist in the markets since 2013, and till date we have invented from generation 1 to generation 7 recently. And if you allow, I can share the screen, sir.
Yeah, sure.
Sure, sir. 1 minute. Sir, if the screen is visible,
Yeah, it's loading. Yeah.
so
There's the Excel
let
sheet.
me,
Yeah.
yeah. So I have made a summary to introduce the industry colleagues and all the renewable energy developers and EPC to explain the advantage that we have done technologically and how technologically advanced product is available in the market. So if we talk about the first thing, that is the most advanced, how to say, the technology available in the market. If we talk about the main component, that is driving mechanism, because the driving mechanism is very important to make sure the robot passes the offsets. Because if we do the desktop studies, in the desktop studies, the layout is very linear, no offsets, no construction tolerance, and very, very smooth layout. But when we talk about, when we shift from desktop to actual constructional site, so there are so many offsets available on the sites. Understanding our experience and the lesson learned from the last 10-11 years of experience, in 2022 end, we have shifted from chain and sprockets to the gear-based transmission. That is the most technologically advanced technology in the market. If we say Solbright is the only one that propose gear transmission. So I understand, like in the third, fourth generation, we were also having the chain and sprockets. And with the gear transmission box, how we can technologically advance. One is the mechanical strength. So gear drives are the most robust one that allows to pass on the highest offsets. Even if we talk about in the tracker or the fixed tilt, the tolerance on the site is even 50, 60 mm. So with this gear transmission box, we can have the, the chain and sprockets. One thing is velocity is not constant, and sometimes robots get stuck. This is from our 7-8 of years of experience, and then we implemented this. One thing is mechanical strength. Second is the service life. And if we talk about third, the transmission efficiency. And the fourth is the most reliable, and the constant velocity allows the robot to pass on the vertical, horizontal, and angular offsets with a minimal space. Second thing, what we have done advancement is the robot body, that is aluminum. As we are installing more than 8 gigawatt of robots in the high coast area in Khavda solar plant, we understand from our experience from the third, fourth generation that if we use steel or ZEM or any other material, the corrosion is very inevitable thing. So if we shift it to the aluminum, we can cater to the high corrosion environment. Third thing, I would like to explain, because many projects are coming with Game Change, Next Tracker, Arctech. So many tracker companies are in the market, because with the tracker, people has to put DC capacity less. So till 2018, what was happening? People were using the disengaged flexible bridge. So what was happening in case of there is a deviation between adjacent tracker, like one tracker is going plus 60, another is going minus 60 in case of backtracking or some error or something, the bridges were getting disengaged. So what was happening? Because in case of tracker, the tracker is in movement from morning 8 a.m. to 7 p.m. At 7 p.m., when the cleaning operation has to start, the manpower, the O&M technician has to visually check the bridges, get it engaged, and then the cleaning was starting. We understood this issue and invented and patented this non-disengaged flexible bridge, that is plus minus 70 degrees. And if we talk about angular tolerance deviations, if we talk about adjacent trackers, one tracker is and the another tracker. So any mix we talk about, irrespective of Game Change, Next Tracker, the maximum angular tolerance that the tracker company provide is plus minus 4 degrees. So what we did to ensure that this tracker deviations are passing easily, we ensured torsional brackets on top and bottom of the transmission box. So that allows robot body to twist plus minus 20 degree, and the angular deviation between adjacent MMS and the trackers is plus minus 70 degree. And sixth thing that is most important that we talk about in Rajasthan or Khavda, that are high wind area. So if we talk about the wind lock mechanism, so we have uh, invented the most reliable wind lock mechanism that is on the top and bottom of the docking station, because we have seen in the past many wind cases happened where wind was affecting the robots. So to ensure the safety, the possibility, the environmental conditions, and the site construction tolerances. So what we have done from the generation 6, we have launched the most advantage the robot in the market. So that's how I would like to explain the technological advances, and that is all from my side. Atul.
Yeah, thank you, Priya, for that great insight on the technologies and what are the best things you can put it in the solar panel system so that it doesn't impact the solar panel also, right? So I have seen that many companies have different configurations of the robots. Some are running on the edge of the frames, and some are very small and they run on the panel itself. So there is a possibility that it may exert some pressure and it may damage the panels also, right? And a very good feature your robot has, telling that during the wind also it has the locking mechanism, right? I think somebody proposed that I don't run my robot during the wind time, but you have a proposal to run during the wind time also with the braking system. So that's
Sir, actually the thing is this wind locking is positioned at docking station. So
okay.
as your question number one was the like robot is integrated with IoT and AI. So what
Yeah.
happens, because this robotic server is integrated with your plant SCADA and the weather station. So it continuously take data from your weather station. So one thing is robot operate till 15 meter per second of wind speed. As soon as the wind speed goes 12 meter per second, it is integrated with your WMS. It takes the weather station data, gives a trigger command, and robot comes back to the docking station. Situation two, if robot has already traveled the quite sufficient, maybe 1 kilometer from the docking station, that is the rest position. So what happens in that situation? Because as I told you that we define the algo, we import the array layout, we define the emergency parking position. So what happens in situation two, if the robot cannot reach back to the docking station, it automatically detects the distance from the docking station. And because it's an AI based, it is capable to make a decision based on the distance from the docking station. So situation one, it takes a decision to come back to the docking station. Situation two, if it is far from the docking station, it take a decision to come for the parking at the nearest emergency parking point. That is the, how to say, the fixed bridge. And second situation, when I told the top and bottom has the locking mechanism. So what happens? The locking mechanism work at the docking station. So if the robot is parked at docking station and wind speed like goes 50 or 55, the robot can withstand up to 55 meter per second at the docking station. So that's how, sir, the operation principle is for the robot.
Thanks a lot. Rohit, you'd like to add any points from your end?
Yes, sir. Thanks, Priya, for the wonderful inputs for the robotics. So I will like to that add some pointers, important pointers for this. That nowadays, when we have a discussions with the PCs and the developers, like when the robotics are in the boom initially, okay, so the robot weights are much very heavier nowadays. That the structures, the MMS, the tracker designs are been designed with the optimized design. So we also getting a request from the all the client sides that the robot weights are the concerns to be, what are the weights to be there. So as per the solar lit stands, where the where initially we were at generation 1, now we have been R&D department, with the help of the R&D department we have been gone to the generation 7 robots, which the very lightest robots and very efficiently. As well as the next point will be that there are some combinations in the projects are ongoing, like fully automatics plus semi automatics. But the semi automatics, the costings are very much higher, like in the way of the manpowers for the longer times. So to tackle that thing, that shuttle robot systems are being introduced by multiples of the robotic companies, especially like SolarLit also will have the shuttle robot technology, which eliminates the hurdles of the semi-automatic robots and reduce the cost for the manpower for the longer time. As well as the clients also required the semi-automatics, where they have the provisions that they need in semi-automatic for the shorter rows. They request for the SCADA integration. Generally, the semi-automatics robots are not being integrated with the SCADA systems. They are just lift and shift to the another rows. So now the R&D departments are going over the semi-automatic robots with the SCADA integrations to provide the status over the locations, as well as the robot health issues and troubleshootings and everything. And the important part where the robo where stands, it's some main component we can as a consider. All the components are main, but the main component is the brush. It the brush, where the life of the brush, which is the been the important key part for the robotics. It's like where we have to design, and we are in continuous R&Ds are going at for the durable brush designs, better cleanings, and the longevity and the life of the brush, which plays an important key part for the robotics and the cleaning efficiencies and everything, where the all the DCTs are be linked with the brush also. So and now the structure part, where the nowadays MMS trackers like game change and everything where are coming with the dual row systems, where the bridges are with are been getting obstructed at the fixed bridges are getting obstructed at the driving locations at the. So generally the designs are being coming and integrated the robotic structure with the latest trackers design itself. So uh, thanks for this, I have to add this only. Thanks.
Thank you. Thank you. I think, Charu, I'll ask next question to you. So how does this robot cleaning impact the energy harvesting and also the performance of the solar panel asset itself?
So, so as you know that the robotic cleaning, it is cleaning your solar panels at the sometime non-generation time also, and as it's clean on daily basis. As in the starting, I told you, in a water cleaning, the cleaning cycle is 15 days, or it could be 10 days. Whereas in automatic cleaning or robotic cleaning system, it is daily basis. And as the more the modules are cleaned, the generation impact is higher, and the generation impact could be higher as much as 2 to 3%. And we are reducing the soiling loss, because any of the analysis which we do, commercial analysis, the soiling loss is considered between 2 to 2.5%, and that is a major impact which automatic robotic system is eliminating, and that is where the generation increases. And as the generation increases, you can have a lower LCOE. And here comes the SunPure, where as a SunPure, we also manufacture robots, and it is a Chinese-based company. And we also have our own patents in our robots. And in the starting, as told, that it is an IoT-based, AI-based system. It is having a LoRaWAN communication system, and we consulted our developers and EPCs that how to optimize the solution and achieve the lowest LCOE. So yes, as the generation is high and the capex is there, we help the clients to reduce the LCOE, and this is how the generation is also impacted by reducing the soiling loss.
Okay, thank you. And the next question is to Kalpesh. So how the organization should evaluate the cost benefit ratio of investing in robotic based cleaning? Kalpesh, you join back.
Yes, Mr. Sundar.
Thank you.
So I think I'd like to start with, first of all, evolution of module cleaning system. After that, we will come to the question how the cost benefit analysis works for the developer. So let's say in early 2000, we were having a manual cleaning system using module cleaning brushes, then pressurized jet, tractor-based system, and levers. So that system, I think, ran from 2000 to around 2012. At the time, point of time, I think the plant size was very small, like 5 megawatt, 10 megawatt, and the number of projects were also very less. So people were using that, and it continued. And still, there are certain small projects who are using that system due to several reasons, like operational challenges, commercial challenges, and the compatibility of module mounting structures. So after that, around 2010 to 2015 was the era when the dry cleaning system started to develop in the market. So people were coming up with like air pressure jet, then dry cleaning mops, and robotic arms which can be mounted on the tractor or another similar vehicle that can clean the modules. So it was the era. It ran for a certain time. In still some of the plants it is working running, but nowadays the economics of that is not working out. Then came the era of automatic robot cleaning system, as well as the semi-automatic one also, I would say. So it was the era between 2015 to 2019 when the development has happened. So I would say that the module cleaning system has came long way. During this automatic cleaning system development, I think developer face many challenges like serial failure of child part of the robots, then service support from the OEM. Some of the developer has to replace their entire system of module cleaning, I would say. So nowadays, I think the automatic robotic cleaning market is little bit mature, and there is the surety that it will sustain for the lifetime of the project, and it will continue. I can say that the service support. So in that sense, I would say the robotic cleaning system is matured enough so that developers can select it without any hesitation. Now it comes on like how the economics will work. So as I earlier said, there are three key pillars, right? First one is the your return of investment. Second one is like what are the operational challenges in manual cleaning versus automatic robotic cleaning system, and third one is the sustainability. So already I have talked briefly about how the economics will work. So let's take one of the example as a benchmark, right? Every project cannot be the same. So I would take a benchmark that there is a plant wherein average row length or the area length is somewhere around 500 meter. Tariff of that plant is somewhere between 2.5 to 2.6 Indian rupees. And module size is somewhere around 540 watt peak. If I do the mathematical calculation on that, so my capex per megawatt will be somewhere around 2.5 lakh rupees for the robotic cleaning system. Average energy gain means average energy gain in robotic cleaning system versus manual cleaning will be somewhere around 1.7% to 2.5%. So for mathematical calculation, I have taken 1.7%. So if I consider 1.7% energy gain versus manual cleaning system and 2.4 lakh rupees of capex, my return of investment will be in somewhere around 2 year. Means if I have invested 2.44 lakh for 1 megawatt, after 2 year I would have recovered that money through the generation gain plus OPEX saving. Because if I compare the OPEX of robotic cleaning versus manual cleaning, robotic cleaning OPEX is somewhere around zero 0.2 lakh or 20,000 Indian rupees per megawatt per year. While if I have to do the 18 cleaning cycle with the manual system, I have to incur somewhere around 49 to 50,000 rupees per megawatt per year. So I have an OPEX saving as well as I have an energy gain, right? So my NPV of the investment will be somewhere around 450%. So if I have invested 1 lakh in the robotic cleaning system now, its net present value at the 9% of coupon rate would be 4,50,000 rupees. And uh, internal rate of return, which are the key parameter for any developer to decide whether we should go for the investment or not, would be between 45% to 50% for the configuration I have said. So in general, plants will not be the same. Like some, there will be some plants in Middle East where there is a shape of the plant is square and they can have an average row length of 750 meter to 1 kilometer. While there could be some plant in India where the shape of land is like ginger. There are as many as rows like average area length could go from 250 meter to 750 meter. So if it is a 250 meter, then also your IRR will be somewhere between 20% to 25%. If it is 50%, 500 meter average area length, then it will be somewhere around 45 to 50%. And if you are lucky and if you have an average area length between 750 meter to 1 kilometer, then your IRR will be somewhere between 80% to 100%. So in an economic sense, to select the robotic cleaning system is no-brainer. Second pillar would be like operational challenges. As I told you, once the labor comes in the plant for the manual cleaning system, it comes with many challenges like stoppage of work, vandalism, theft, then uneven cleaning. There could be absence of manpower, which can lead to your average soiling rate, which is assumed like 2 to 2.5%, to 3 to 3.5% on average. So over there you have a already I can say that the loss of 1 to 1.5% in your model due to uncertainty of labor. So on that front also, robot goes means on the winning streak, and there is no brainer to select the robotic cleaning system. Third comes on the sustainability. So in sustainability, as rightly Mr. Atul introduced during the initial presentation, we are burning around 23,000 of kilogram of CO2 for one cycle of module cleaning of 100 megawatt. So we are means electing tons of CO2 by selecting module cleaning robot. Also, if I say there is a usage of nearly around 83,000 liter of water per megawatt per year for 18 module cleaning cycle. So that is also a huge amount of water. And to be specific, like areas like Rajasthan, some part of Gujarat, and some part of Maharashtra, which is water scarce, to utilize that such a huge amount of water is like suicide, I would say, for that particular area. So in that terms of sustainability, to selection of robotic cleaning is no brainer. So overall, in a nutshell, I think for any developer, it makes sense on all front to select the robotic cleaning system. That's all.
Thanks a lot, Kalpesh. I think you hit the bullseye, right? I think even our chairman, ex-chairman, NRN always says, we believe in God, but come with the data. I think you have come up with lots of data to hit the bullseye, right? I think moving on to the next question, Priya, over to you. I think what are the challenges faced in adopting the robot-based cleaning in India, and how we can overcome that?
I'm so sorry to interrupt in between. I would request Priya ma'am to wrap up fast so we can take the questions from the audience as well. Hope this is
Okay,
Sure.
fine.
Priyanshi.
Sure,
Noted.
sure.
So if we talk about the upfront challenges when we adopt robotic cleaning in the market, first thing is initial investment cost. As Kalpesh had pointed out, finding even shape land where the row length is more than 500 meter or 750 meter is quite tough in Indian market. If we talk about Khavda, you can find the longer length, but if you talk in Rajasthan or any other place, people are like developers and EPCs are struggling to get even shape land. So if we talk about thumb rule, it might be a scenario in the even shape land, one robot can clean 1 megawatt for fully automatic. But if we talk about uneven land, the robot quantities may go 5 to 6 numbers per megawatt. So the land shape is plays a very important role when we define the robot application. So adoption is like one thing is when we're planning the robotic or we initially designing the plant. So if we involve the robotic partner from the initial phase, maybe we can optimize the number of robots. and that's how we can have control over the robot quantity and the cost also. So that's what my first is challenges and second is the solution. Thank you, Priyansi.
Thank you. I
Thank
think
you so much, all the panelists, and special thanks to Sundar sir for superbly managing the session. And all the panel members, thank you so much. So, with this, we come to an end of the panel discussion. Let us take some questions from the audience.
yeah, I think there are some questions from the audience. I think Dilip Kumar has added some 3 4 questions. I'll take it one by one, right? So, what are the best robotic solutions for sites that were not built for robotic cleaning, right? So, again, in fact, our Hyderabad campus has a lot of undulations. It doesn't have a plain terrain. So even moving the cleaning robot from one panel asset to the other panel asset itself is a problem, right? So again, we need to have the docking station, and the docking station has to move around, right? So again, so those are the challenges we also faced in our own installation at Hyderabad DC. But I think maybe the panel also can share their views.
Can I answer this?
Yes.
Yes, sure.
Yeah. So, especially for the plants which are not designed for the cleaning robots, we have a vehicle-based solution where, there is no need for the structures or bridges to be constructed for such kind of power plants. So, please allow me to share, one video.
Sure.
Can you see the video?
Yeah, study. Okay, you are talking about the future trends, right? So instead of the docking station, you have a mobile robot which is operating the cleaning robot. Gaurav, these videos are available in YouTube. Maybe you can share that
Sure, sir.
link
Sure.
also, so that
Sure. I'll share the link.
participants will be benefited.
So,
So if you can share that link, it will be great.
yes. Yes, I'll share the link of the video. So this is our solution for the plants which are not designed for the robots earlier. So you see, it senses everything by its own, like the misalignment or any kind of. It can take up to 16 degrees of undulation also in the power plant. So this is the one solution where robot will go in between the rows, and the cleaning robot is attached to the arm, and it will move along uh, with the vehicle. So this is the one solution. The other solution that we have is where a combination of our G1 and G2, which is basically for large power plants, where what we are trying to do is we are trying to reduce the number of cleaning robots which runs on the frame of the module. So basically for 2 rows, one number of G1 robot. So for a power plant which is larger than 400 500 megawatt, so what we have seen is there is a 15 to 20% capex reduction when you use a combination of G1 plus G2 for a bigger power plant, maybe for 400 500 megawatt plus.
Okay, thank you. So
Thank you.
moving on to the next question from Dilip Kumar. Is there any adverse effect on the modules from the robot's bristle itself? Will the asset will get impacted due to the bristle wear and tear or the rubbing force?
I'll like to answer this question.
Yeah.
So, Dilip, you are absolutely right. So, although there are multiple tests happens with the robots before implementation of the robot in the large scale power plants. So generally, what we need to do when we select a robot, or of course, before selecting a robot, we have selected a module which will be implemented at our solar power plant. So we have to generally take an approval or a consent from the module supplier that whether I am putting a X brand of robot on your modules, whether it will be impacting the life of the modules or not. So the module supplier itself gives the consent that yes, there is no impact on the warranty, or there is no impact on the performance of the power plant or the module after using this kind of robot. But if you read the complete report, which can be provided by the robot supplier, you'll find a minor impact is always there, but it is not an immediate impact which can be seen in 2 years or 3 years of time. But if you'll see a larger duration of time, let's say 10 years or 15 years of time, then definitely yes, it have an impact, but it is almost negligible as compared to what gains we are having in current time.
Thank you. The next question is it difficult to get the spare parts when any OEMs discontinue their business or manufacturing in India? So how to take care of this situation? Do we need to source from anywhere else, or we need to look for some compatible products?
I think Kalpesh should answer this because he is one of the largest
I,
user of the robots.
I think yeah. Let me answer this question. So this is possible and have happened in the past also. I would say that for the large portfolio, it has happened. Like we have supplied the robots, and later on, due to XYZ reason, they discontinued the services. So there are many views. Okay, there are many ways to tackle this. First of all, like parts which are mechanical in nature that can be identified from the open market, like motors, gears on the chain sprocket. It can be easily developed in open market through reputed vendors. And there, after that comes like controlling part of the robot. So in a controlling part, if you do not have a like algorithm how the robot will run, definitely you are going to do the reverse engineering of that product. So reverse engineering is also possible, but for that you need to have a certain capex. So in my experience, wherever such kind of things happen, people has gone for the reverse engineering or shifting of a portfolio of one OEM to the another OEM because he is doing the same business and they have already such kind of developed projects, right? So you can just identify suitable another OEM who can take it up the responsibility of another portfolio and who can maintain it. But what is my suggestion? I think whenever you are doing the contracting for the supply, you do the long-term service and supply agreement and bind it the OEM with performance bank guarantee or supply guarantee, whatever the legal framework you have based in your portfolio, so that such kind of situation do not arise.
Yeah, thank you. I think the next question is the AMC of robots for projects of smaller size is a challenge currently. I think after sale service is not good. That's what is the feeling from Vaibhav and how it can be taken care. And on the previous question again, even 3D printing is also another option to take care of the parts, right? So that is also another option. Maybe a little bit costly if you go for one product, but whereas if it is multiple parts, I think 3D printing also will work out, right? So how do you address the sales service and aftermarket service for the smaller capacity plants?
So, Mr. Sundaresan, I think being a user, let me answer this question also. So, I am also operating many projects with the smaller project size, having a 3 to 4 robots, or in some sites we have like 8 to 10 robots. So, in that, what we used to do, while purchasing the robot itself, we will have a list of the spare part which is recommended by the OEM as well as based on our past experience. So, first thing, you need to have a all kind of spare part which is needed on site. Whether it is a one robot or 3 robots, you need to have a spare part. Secondly, we used to consider one training session for our site technicians while installation. So OEM will come down to site. They will train to the technician that how to replace each and every component. So you have availability of spare, then you have a trained technician to replace the spare parts. So whenever there is a fault, you can take a remote support from the OEM and replace that parts. And I think that model is perfectly working for us for all our small projects. I think in my portfolio, whenever means earlier we were having a 6 to 7 small plant with a manual cleaning system, we shifted all that plant to the robotic-based cleaning system, either semi-automatic or automatic, and we are using this mechanism to tackle that issues.
Okay. Thank you. I think some 2-3 questions I'll combine because there are multiple questions available. So some questions are related to the soil losses, right? So what is the level of soil loss and how frequently we need to clean, right? Again, definitely it will change from place to place. And again, urban area or village area, right? Definitely and again the wind also will have the factor. So again, you can answer it. I think mainly for some or 2 or 3 questions on the soiling losses.
So can I able to highlight the over this?
Sure.
Yeah. So regarding the soiling loss, where we can take an example for the Rajasthan side. So for the fully automatic daily cleaning two-way, we can able to give the soiling loss guarantee of the 99 to 95, 99.5% soiling loss guarantee. We can able to give it, where we can able to where we can say for every 2 days, then the soiling loss may get reduced. So we can able to guarantee about to 98.5 percentage for the soiling loss for.
Okay.
Thank you.
Thank you. And Saswata has 2 questions, and again I will club it. And so, what is the kind of pressure we can apply on the panel, and what is the standard test for approval of robotic cleaning system? Is there any standard available for certification of this robotic cleaning system? Because some of the OEMs will not give the warranty guarantee if we apply more pressure, and due to robotic cleaning, if the things get damaged, right? So how do we take care? So how do we ensure that the pressure on the panel does not increase beyond the specification of the panel itself, right? So what are the standards and other things available?
So there is no current standard available as per IEC, especially for the robotic cleaning system. But yes, as I explained earlier, that before implementation of any robotic system, you need to take a consent from your module supplier, so that the warranty should not be void.
Okay. And there are some solar panels which doesn't come with the frame. So how do we take care of those kind of panel cleaning?
So let me add my views on this.
Yeah.
So if we talk about, because First Solar has now Indian registered company, and they are manufacturing more than 3.3 gigawatt here, and they have ALM registered also. So First Solar modules are being used by most of the developers now. So what happens when it's a thin film PV module and the robot have the driving wheels, and when it's a frame, it's running on the frame. But when it's without frame, the developer and EPC has to ensure that they put additional purlin on the top and bottom to support the robot wave. That's the only solution available for the frameless PV module, so that there is no harm to the First Solar or any other frameless PV module, and the robot get the support.
Okay.
So the steel structure around, I think, 400 to 500 kg per megawatt will be an additional for the purlin.
Okay, thank you. I think there is one interesting question from Ajmal. I think we talked about solar panel cleaning farms on the ground mounted, but if there are any floating solar projects available, what is the kind of cleaning mechanism we need to use? Is there any system available, or any R&D is going on for that? Because I think some places I have seen that floating systems are getting installed recently.
I'm not sure whether any of the available participants have that kind of system. So if it is there, then definitely it could be a wonderful thing.
Okay.
But I can say that it will be similar system, similar to tracker, wherein like in a floating
Okay,
solar you have a
so
base.
I believe that with this we can wrap up the session,
Yeah, I think
as we have
I think any
exceeded the time
unanswered
as well.
question, maybe we can capture it and send the reply directly to that participants if required, Priyanshi.
Yes, sir. Sure. We can. The speakers can answer in the chat box itself.
Yeah.
Okay.
So, with this, we come to an end to today's session, and thank you so much to all the panelists, and a special shout out to our attendees for extending their time and support to the event. And many special thanks to Mr. Sundar for superbly moderating the session and combining the interest of all the panelists. As we conclude this event, we assure you that we'll be back soon with some exciting sessions. So the floor is open for networking now. Till then, bye from our end and do take care. Thank you so much, everyone.
Thank you, everyone.
Thanks a
Thank
lot.
you,
Thank you,
everyone.
everyone.
Thanks,
Thank you.
Priyanshi.
Thank
Thanks,
you.
everyone. Bye.
Thank you so
Bye
much.
bye.
Thank you.
Bye.